All right, boys and girls, welcome back to the drive-through for a special 7.7 X Factor edition. Sponsored by the deli. Hungry? Stop by the deli. Get yourself a sandwich. Very hungry. All right, let's do some pause and read. All right, so we're just drawing blocks, rectangular blocks. We know all about this. So they're saying sometimes they want one side of the block to be the standard length X. So hard to draw a straight line with this thing. X. And the other side of the block to be 2 inches bigger. Okay? Draw and label the block. Done. Write 2 different expressions for the area. So the area of this block in terms of X could either be X times X plus 2, or you could rewrite that as X squared plus what? Plus what? Plus 2X. Very good. Okay? Sometimes they want blocks with one side to be the standard X and one side that is 2 inches less than the standard size. So, this one I don't exactly understand how they want us to do it. I'm going to have to change colors. Well, see, this is what's silly about the blocks. In my mind, I would do this. Yeah, like a deletion. Okay? So, we would call this ViewSonic -2. Right? And we're like taking that away from it. So, one way to write it would be what? Well, let's write this one first. X times X minus 2. Or we could rewrite that as and I guess that makes sense visually. Okay? There are many other size of blocks requested, with all the side lengths being based on the standard length X. Draw and label. Use your diagram to write 2 equivalent. Verify that the expressions are the same. All right. One side is 1 inch less, and the other side is 2 inch more. Right? So this side is X minus 1, and this side is X plus 2, right? And keep in mind, the actual block, these are gone. Let's see. I don't know if this is going to work out visually, but we'll see. So, A of X, the area is X minus 1 times X plus 2, right? Foil it, you get X squared plus 2X minus 1X minus 2. I think it works. So you get X squared plus 1X minus 2. And if you think about this, this is like 1X and 1X, but this is negative 1X, and so these will cancel each other. Is kind of what's going on. Can we maybe not focus so much on the picture from here on out? Let's just do the math.
Yeah, let's do that.
Okay? So, A of X, one side is 2 inches less, and the other side is 3 inches more. Foil it, X squared plus 3X minus 2X minus 6. So what that equals is Okay? One side is 2 inch more and the other side is 3 inch less. Well, it's going to be different. So x squared minus 3x plus 2x minus 6 minus 1x minus 6. Okay? So if we did our visual, I think this one would have a bigger area than that one because the plus 1x compared to the minus 1x. Okay? One side is 3 inches more and the other side is 3 inches less. Minus 12, which equals okay? And for number 7, I will do the picture again. I just didn't feel the need to do it every time. So one is 4 side more and the other is 3 side less. So eventually we're going to take out all of these red blocks. So what you see in black is the actual rectangular surface, I think, okay? So this was x minus 3, this was x plus 4. All right, so you get x squared, ViewSonic, x squared plus 4x minus 3x minus 12 So I guess what that means, Carson, is all of this stuff equals 1x. But I think I buy that. I'm not going to go into why. Okay? Here's the minus 12. Oh, no, yeah. Look, you got minus 3x plus 4x. And then here's your minus 12 right there. Okay? Got it. An expression that has 3 terms is called a trinomial. You're going to get used to this. This is a very important thing to understand. The A, B, and C are called the coefficients. Okay? Look back at the trinomials you wrote in question 3 through 7. How can you tell if the middle term is going to be positive or negative? Ah, I got it. If the number that's being added is bigger than the number that's going to be subtracted, then the number in the middle will be positive. If the number that's being subtracted is greater or a greater value than the number that's being added, then this number in the middle is going to be a negative. Okay, so that's what they're looking for that one. One customer had an unusual request. She wanted a block that is extended 2 inches on one side and decreased by 2 inches on the other. That's not strange. Will this have the same area? Here's the question at hand. Is the area of that block change color. Is this area the same as that area? Well, let's just do the math. This is why we do math. So this is x minus 2 times x plus 2, right? We'll find out. What's the area of this one, Carson? X squared. What's the area of this one? No. X minus 2 times x plus 2. Which was bigger, the negative or the positive? Neither one. Okay, so we're going to FOIL. X squared plus 2x minus 2x minus 4. Right? You got to take out all those. So you end up getting x squared minus 4 for this one. X squared for this one. Do they have the same value? They do not. So what we just learned is that if these two values are the same but opposite signs, what will happen to the b? She gone. Alright, number 10. So, use the result. Is the pattern a way to predict the two expressions of the area when one is increased and decreased by the same? Try modeling these two problems. Look at your number to number 8 and see if you can find a pattern. X squared plus 1x, or that's minus 1x, minus 1x, minus 1. What is that going to be? X squared minus 1. She gone. Okay, what's this one going to be? X squared minus 3x plus 3x minus 9. What's that going to be? X squared minus 9. She gone. Okay, so what is this? It's x squared minus a squared. Right? Right? ViewSonic. Does that make sense? These are starting to look like equal signs. Gosh, I'm just not a big fan of the ViewSonic today. X squared minus a squared. Does that make sense? You see the pattern? What's negative 3, or what's 3 times 3? 9. That's negative 9. 1 times 1. 1. That's negative 1. Is that it? Some customers want both sides of the block to be reduced. I'll draw A. I'm not going to draw B. I'm getting sick of these blocks. Okay, so now we're taking away 2 from this side and 3 from that side. So this is like a x, and this is a minus 2. That's negative. Well, I'll change. And this is x minus 3. So it looks like cancel. It looks like this is negative 2x, this is negative 3x, and this is negative 6, right? So my guess is we are going to have a positive x squared minus 5x minus 6. That's my guess. What do you get? Plus 6. I'm not a big fan of that. Right? It is a plus 6. So I don't know why. I don't know how to explain that. I really don't. But it's definitely plus. This is this is why I don't understand. I don't love the visual representations. Okay? I just don't. Maybe I'm drawing them wrong. All right, so what's this one? This is what you need to know how to do. Is just we're still just foiling. X squared minus 4x minus 1x plus 4 Okay, so when will C be negative? When we add to one side, yes, and subtract from the other. ViewSonic. We almost done? No? I'm going to pause. Talk to Becky real quick. Alright, now this is where the magic happens. This is called factoring. Okay? We're trying to find the original order that got us to that. So we did some of this yesterday. Two numbers that multiply to be positive 18 and add to be 9. 6 and 3. I'm not going to do this every time, but let's check our answer. How would you check your answer? FOIL it. Yes, x squared plus 3x plus 6x plus 18. That is equivalent to? Did you factor it correctly? Heck right, you did. Alright, let's go fast now. Multiply to be negative 18 and add to be 3. X, no. Add to be positive 3. Did I say negative 3? I meant positive 3. X plus 6 times x minus 3. Right? Alright, multiply to be negative and add to be negative. Now the 6 is the bigger number. Right? They multiply to be negative 13, or negative 18. Add to be negative 3. Multiply to be positive. Add to be negative. Now tell me this, Carson. What's the only way two numbers can multiply to be positive and add to be negative? Nope, they both have to be negative. They both have to be negative, right? They don't have to be the same number. And so what are these two numbers? You follow that? Alright, multiply to be 4, add to be negative 5. So once again, they multiply to be positive, and they add to be negative. What do they have to be? They've got to be negative. What numbers multiply to be 4 and add to be 5? 4 times 5 isn't 4. Negative 4 times negative 1 is... What's negative 4 times negative 1? Positive 4. What's negative 4 plus negative 1? Negative 5. Multiply to be positive. Add to be negative. What do they have to be? Multiply to be 4. Let's see. 2 and 2 doesn't work. I don't think this one's doable. Multiply to be positive 4, add to be negative 3. They both have to be negative. That's not factorable. I think that's a typo, but I swear that's not factorable. You come find me if I'm wrong about that. Anybody watching this video. Let's do G over here. So x squared plus 2x minus 15. We're looking for two numbers that multiply to be negative 15 and add to be positive 2. That means we have a plus and a minus. Gosh darn it. What numbers multiply to be 15?
Plus 5 and negative.
You looked unsure of yourself. So if you're unsure of yourself, what should you do? What should you do? You should check it by foiling it. X squared minus 3x plus 5x minus 15. What does that give you? On your test, are you going to check your answers?
Yes.
You better check your answers. And we're over at the 20-minute mark. How do you factor a trinomial? Do a riddle. You're looking for two numbers. They add to be C, and they multiply to be what? To be B. No, we got that wrong. I'm so wrong about that, Carson. What do they multiply to be? They multiply to be C. And they add to be B. You owe me a smack. One smack. Is that it?
Yeah.
Boom!